Welcome
to the joy of coding.
Hello and welcome to episode 431 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. We're going to be live hacking on some Firefox stuff. Let's get started, see what's going on. Let me start by sharing my screen. Yeah, it's February 25th, 2026, episode 431. A reminder, no plan survives breakfast. I think I know what I want to do today. I think I know roughly what I want to tinker with and move forward and clean up and whatnot. But who knows what'll happen? It could be that an emergency crops up and I have to deal with it, or we get distracted or sidelined or something. That's all good. We may end up just answering questions. Someone might have a really good question that shows up in the Live Hacking Matrix channel or in the Twitch chat, and I'll just spend the entire time answering it. Who knows? We'll just deal with things as they come. That's the first thing. The second thing is that the agenda that we're looking at, depending on where you're watching the stream, it may be in a different location, but you have access to it. So if you're watching this on YouTube, it'll be down in the video description. If you're watching this on Mozilla, it's over there in the details, boop, 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 over there. And if you're watching this on Twitch, it's down in the channel description or channel details. And as I update the agenda, if I add text or something, this little spinny will spin. And then if you reload, you should get the most up-to-date version of the agenda. Right, so today is brought to you by Error Code 431. I don't know what I'm looking at here. This is from Keanu.codes. This is the graphic for Error Code 431. I don't know what the story is. There's a lot going on. I don't know how much I believe that this image is real. I mean, that cat does not look like it's really wearing this hat. The cat looks like it's been shopped in. I suspect that this predates the sort of the modern generative AI image. This reeks to me of old school Photoshop where a person made this by hand. But maybe not. Maybe this is from a film. Maybe this is a Hollywood special effect. I have no idea. If you know what this is from, let me know. But I don't think Keanu.codes restricts its... I think its majority of the images are from film, but I don't think there's a rule that says that every image must be from a film. I think it's just every rule must have Keanu Reeves in it. And that's definitely the case here. We've got Keanu. This looks to be in the 90s. I'm thinking maybe near the Matrix/Speed. That's the era we're talking about here, or Devil's Advocate. And then a cat wearing a sombrero. So let's take a look at the error code here, 431. Let's see what that's about. Request header fields too large. I see. It's a big hat. 431, request header fields too large. It's a client error response. Indicates that the server refuses to process the request because the request's headers are too long. The request may be resubmitted after reducing the size of the headers. So this can be used when the total size of the request headers is just too large, or when a single header field is too large. To help clients running into this error, indicate which of the two is the problem in the response body, and ideally say which headers are too large. This lets people attempt to fix the problem, such as, for example, by clearing cookies, because oftentimes cookies are included in the in some cookies. I think cookies are just in general included with the request. And those, for better or worse, can contain quite a quantity of information. Servers will often produce the status if the referrer, that's with one R, classic, URL is too long, or there are too many cookies sent in the request. So in this particular case here, we see a get requests being sent to /doc, and this is a bunch of cookies are being sent, and maybe it's too much. The server's like, I can't deal with this. The server responds and says hey, that's too much. The cookie header was too large. And that's actually in the body of the response. It doesn't say that the cookie, the error code headers do not include a way of programmatically determining which header was too large. But hopefully you as the client can do something about that. So there you go. 431, request header fields too large, and indeed this hat is pretty big. What else is there to say? Well, today it will be a slightly shorter episode. I have an alarm set. I have a meeting at the top of the hour that I cannot miss. Unfortunately, it is a very important, very, very important meeting, and I have to be there. Let's see. Oh, that's interesting. I'll have to deal with that later. Sorry, I just got a message from Mozilla Monitor showing me that there's a breach has been detected, but I'm not gonna give more details, but I'm not too worried about that one. But I'll have to look into it later. There's been a breach. That's a reminder. If you're not sure what Mozilla Monitor is, this is unplanned plug. I'm gonna do a plug here. Monitor.mozilla Mozilla Monitor. Let's just look it up. Mozilla Monitor is a free service that will allow you to use your Mozilla account, and it will check to see whether or not any of your accounts have been included in like a known breach. Like if you supply it with you verify you have an email address, you own the email address. I mean, I guess it's the one associated with your account, and maybe the other one's associated with your account. And then Monitor will do the work of paying attention to breach alerts that happen out in the wild. Like if you're familiar with Have I Been Pwned, there are these giant databases where like if people report that like, oh, service such and such has been breached and a bunch of stuff's been leaked, that information is like, we don't hold on to the breached information. I believe we get hashes from Have I Been Pwned. I don't exactly know what the relationship is, but we partner with Have I Been Pwned? Have I Been Owned? Have I Been Pwned? And we can just do a quick lookup and say like, yes, your email was included. This is like a classic sort of set what's the term I'm looking for? What is a Bloom filter for? Is does the set contain an item problem? And you do it in O of 1 with like a hash lookup. Maybe it's Bloom filters, stacked Bloom filters or something. But the Mozilla Monitor dashboard doesn't show it yet, but it does show up on Have I Been Pwned. Craig got that breach message too. Yeah, I'm not too worried about it. So here's a pro tip: never use the same password on like use a good password manager. You can use the one like Firefox will generate secure passwords for you, or you can use something like KeePass or 1Password or LastPass or literally anything. Just use a password manager and don't use the same password for every site. And alongside Monitor, if you're worried about your email addresses being leaked in like breaches and stuff, you can use another free service that Firefox offers called Relay, which allows you to get like email masks. So you can get like emails that look like I've got Relay installed, and so it gives me the ability to quickly generate like disposable email addresses that are mapped to a particular domain, and then those get redirected into my actual email. So in the event that like, I don't know, there's been a breach, or like I don't want to hear from the service anymore, instead of like trying to unsubscribe, I just like kill that email address and then it just stops going through. And I think there's like, that's free. Relay is free. Both Relay and Monitor are free. There are paid variants where like you can I think you get more masks and phone masks. And let's see. Yeah, here's the deal. I'm not trying to sell. Use whatever. What I'm trying to say is use a password manager. Just use a password manager. And don't use the same password on every site. And if you can, use like an email masking service. Relay's a great one, but this is a great way of insulating yourself, because like there are services and stores and online stores and whatnot that you'll want to use, and not all of them will survive cyber attacks, to use a boomer phrase. Like there's and I guess this is always the case. Like, even back in the day, if you had your stuff written down, like maybe you, like an old school mom and pop shop, you might like sign up for a mailing list and like write it down on a piece of paper. I guess back in the day, someone might throw a brick through a window and grab that binder, and then they have your contact information. This is like just the same thing at a larger scale. And some places they'll suffer a breach, and it's not always the technology. Sometimes it's the people. Places get phished. Someone hands over some bad information or trusts the wrong person or gets tricked, and everyone's susceptible to it. I'm susceptible. Everyone's susceptible to getting phished. Use a password manager. Assume, like, when you give information to a site, it is a good idea whenever you're signing up for something and like creating an account or something, is to think about what information is this site learning about me as I use it. And that's not always obvious because they might be doing some shady stuff in the background with data brokers. But what is this site learning about me? And what happens if that information just gets out and gets traced back to me? Not because like, oh, you were doing, you're buying like illicit materials on the Silk Road or something, but like, it'd be embarrassing. Or like it could be used for identity theft, or it could be used to fool a family member into doing something, or who knows. It's like, try and keep that stuff in mind. And it's kind of like, it's a sad state of affairs that you do have to think about those things as you use the internet. It wasn't always that way, but as soon as you bring commerce into a space, you have to worry about fraud, and you have to worry about people trying to take advantage of the fact that money and information is flowing over a bunch of channels to use them for nefarious ends. I want to believe that most people are not trying to steal, but there are those people out there who are just like, that's what they want to do, is they want to steal information. They want to use it to, they're going to sell it, or they're going to use it to get other information or what have you. And the best thing you can do to sort of like build up a self-defense capability is to just sort of like consider the worst case scenario, and then do what you can to insulate yourself with things like email masks and doing breach alerts and using a password manager. Use a good like that is probably the biggest tip I can give, and I'm probably preaching to the choir. I want to believe that everyone who's watching this stream, if you're watching this stream, chances are you have a password manager. But if you don't, or if you're not using the securely generated password manager in Firefox or whatever browser you're using, just something that maintains your passwords, and don't use the same one each time. Don't use the same password for every site. Just don't do it. It's just, that is sort of like account security 101. And I know it's a pain in the butt to have to remember all those passwords, and that's why using a password manager means that you don't have to. In the best case scenario, is like it remembers it for you. You remember the key to the password manager. The password manager remembers your passwords to everything else. And some may say like, oh, well then, like, isn't your password manager kind of like vulnerable? Couldn't someone just steal your laptop and get all your passwords? Like, that's true, but like the chances of, I mean, you want to have some operational security as well by making your computer kind of harder to break into. But like, if they get your laptop, they've got everything anyways, for the most part, unless you're using like really, really nice, really solid disk encryption. And at least you have some level of control over like your laptop security. You have no control over what some shop is doing with your information. You don't even know, for example, like, we just kind of trust that sites are doing the right thing with the password information that you send it. I again, this is me being distracted, and I'll get to work in a second, but I was shocked because this was fairly recent, within like the past year or two, that I signed up for some site. It wasn't for something that important, but I just was like, I have to create an account in order to do a thing, and I had to reset my password. And when it was like, I went through the forgot my password form, and I'm like, okay, I forgot my password because I guess my password manager didn't remember it, or maybe I had, for some reason, maybe I had used their app. I can't remember, but my password manager didn't have the password, and I'd forgotten the password. So I'm like, okay, well, you have my email address. I forgot my password. Please, you help me generate a new one? And so they're like, okay, we will email you instructions. And then what they emailed me was the password. They're like, here it is. Here, this is your password to remind you, which means that they had it. They had the password. They were storing it in plain text. They had access to it. And you have no idea whether a site is doing that or not. You just don't know. So assume that they're getting it all. And thankfully that password was, I have a habit of not reusing the same password. So but if that password had been like the password that I use for my bank or for work or for really important things. You know, now all of a sudden this random site just happens to have it. It's just sitting in their database. And that database is probably, that's not just me, it's every other user of that database or of that service. Their passwords are in plain text. And so if that database is stolen, or, you know, a rogue employee decides to like dump it out and do something with it, that's all out there. And so assume your password will get leaked. Have a plan in mind. Okay, so enough beating the drum there. These are some services that Mozilla offers. There's like, looks like there's a limited time deal. Although we say limited time, I have a feeling, I don't know how limited this is. I think we've been having this limited time offer for a while, but like, this is a pretty good deal. $69. I'm guessing that's the price in Canada. It might be different from wherever it is you're watching from, or if you view this stream from. But like, you know, a VPN relay, grabbing yourself a monitor, like it's a good idea. Okay, enough. Let us proceed. What did I want to do today? Oh, so today will be a slightly shorter episode. Next week, I've already eaten into 20 minutes of it. That's great. Next week, no episode. I will be traveling. I cannot stream next week. So just FYI. All right, let us proceed. What I wanted to do was look at these patches that I've been working on with the new tab cache stuff, and I wanted to think about cleaning it up a little bit. And if you're curious about what I'm talking about, go watch last week's episode and the week before, where I go into more detail, and I don't want to waste more time kind of like rehashing what all that stuff is. But what I was interested in doing, like I'm reusing. How do I want to phrase this? I am reusing a mechanism that we use for caching about home, and I'm kind of grafting in, just for like this demonstration for this prototype, I was grafting in some changes to that mechanism, and I don't know if that architecturally makes a whole lot of sense anymore. And I was thinking of doing something different. Let's see if I can show you where we're grafting this stuff in. New tab redirector. New tab cache. Child. Here. So this is the thing that intercepts and deals with requests for about home and about new tab. For things that are requesting resources, like that resource, about home or about new tab. And I am abusing that redirector for the scripts in CSS that we're serving up from the cache. Because I'm basically using like a query string and saying, okay, if you apply this query string to the end of about new tab, then I also want you to go grab the cached new tab script or the cached new tab CSS. And I don't feel so good about that. It feels messy to me. And so one of the things I wanted to consider was, is it cleaner? I'm going to write this down. Is it cleaner to just create a specialized protocol handler for cached new tab resources in this configuration? So what it would look like is we'd have like an HTML document. Hang on. Can I do that? No? Why won't you let me? We'd have like, how do I insert code? Come on. What is the, here we go. What? Can we do better? Okay. We'd have like an HTML document. This is like new tab. Yay. Oh man. Let's do a multi-line. I want multi-line. Come on, Joplin. Don't mess with me. Okay. We'll call this HTML. We want something that looks like this, like head, title, new tab. It's not gonna look. It's not gonna be that. But one of the things I want to do is like script source equals Moz new tab cached, and then it would be index dot hash. There'd be like some hash dot js. That might actually not be able to be declarative. We might have to do that dynamically, and similarly with styles. You might need, or it'd be like link style sheet type. What is it? Rel style sheet, something like that. I can't remember how you do this manually. Is that right? Yeah, link rel style sheet href. Moz new tab cached, and then styles hash.css. And that might end up having to go at the end, and then you'd have like body div id equals root. That's a classic React thing. So this would probably go like after the body or something. And this might be all programmatic, like programmatically inserted by about new tab child, since the hash would be in a pref. So here's the thing. Each version of the remote new tab is going to include this hash value, and we're going to want to like switch over to it. And so no, you know what? That decision shouldn't happen in the child. That decision should not happen in the child. I think what we should do is we should actually have that be declarative. And it should happen in the head. And instead of including the hash, we just call this like script. And then styles. And maybe just script.js or something. And then over we add a Moz new tab cached protocol handler that can run in the content process, in the privileged about content process. Privileged about content process. And its job will be to message the parent, basically to get a remote stream from the parent for script or for styles. When the parent receives the request, the parent will check for the appropriate let's see. When the parent receives the request, the parent will... Oh boy, what am I thinking here? I think I know what I want to do. The parent will get the pref from... get the hash value from... Oh, thank you very much. You just got a tea delivery. Thank you very much for the tea delivery. Smells good. Smells like decaf, which is what I need. Do we need the hash value. We'll get the hash value from prefs. We'll retrieve the cache entry for the particular resource, like Moz new tab cached script.js. And check that the hash matches the expectation. Actually, I don't think this will be from prefs. It should be from remote settings. Get the hash value from remote settings. If not, fall back to built-in, to streaming out the built-in, the package. I'll say the packaged script. Blow away all caches. Fall back. Okay. The parent receives No, I don't like that either, because if we're in the midst of an update, we do need get the hash value from prefs. After retrieving the stream, kick off a deferred task that will eventually kick a check to see if we need to refresh the cache. If so, I guess it doesn't. Yeah, kick off a deferred task, check to see if we need to refresh the cache. Once that fires, check remote settings to see if the hash has changed. Hash and or version has changed. If the hash and or version has changed, yeah, this is all like commentary. I'm gonna actually, now that I think about it, I should just add this below as text. Okay, so all right. If the hash and or version has changed, download them and stream them into the cache. So here we go. Now we get the caching, writing to the cache. Take hold of the cache entries for both script and styles and hold. Because I believe there is a way content type. Doom. We can doom it. In case some servers responsible or cache into the calling so that to initial. Like, where are the ways we can hold on to? I think it's under cache storage service. No, cache storage. I want to open. Open an existing entry which is complete. For example, not being written. Perform the cache entry check on any thread for optimal performance. If this flag is not specified, okay. Bypass the cache load when a write is still in progress. Yeah. Can I block on... Open cache normally. What does it mean to open it normally? Placeholder for specifying no special flags. Bypass if busy. Let's see what happens. Because what I want to do is, if the cache is being written to, wait until it's done. Hold. So bypass if busy. Open. Callback, truncate, priority, bypass if busy. We get here when the callback wants to bypass the cache when it's busy. Check state under the lock. If we're writing or revalidating, return false. Remember callback. Load opens the lock. Load. Load. If already loaded. Check the index under two conditions. When the disk entry is told to truncate, check there's disk file. If not, when there's a memory only entry, check if there's disk file. If or don't use disk. Just fix the load has already been done as new. Priority, direct load. What does it mean? Like, do we have documentation on what those flags mean? Open normally. What does open normally mean? Basic read only. Open normally. Async open cache entry. I'd love it if that was clearer. Entry pinning. Force valid for no output stream open. Chunk memory exists. Range not valid. Conditional. Open bypass if busy. Open callback, don't fill. Open and bypass. Okay, we don't want that. Doom and read. Yeah, what does it mean to open it normally? Storage. Add cache entry. So let's take a look at the code. Read the metadata for the origin. That's not quite it. Open normally. Is that the only place we actually read it? Open normally. Dictionary origin reader. Who calls you? Dictionary get dictionary 4, which is called under add and accept dictionary headers. This is all no. I don't like this. We are in the wrong place. Let's take a look at async open URI. Let's start there. Async open URI. I want to get a clear understanding. We get our flags. We're going to open up async open URI string. Oh, and then we're going to if we're not using the disk cache. Okay. This is if like we're not initialized or something's wrong. Okay. Make sure that we're getting a callback. We're going to add a storage entry with those flags. Add storage entry, and we're going to pass those flags. Ensure the storage table exists. Look up or insert. We've got our context key. Entry key and context key. Yeah. Entry key. We look it up. And what are we writing that to? Return cache entry table, all entries. Get for the entries. Oh, that's the table. All entries. We look up via the entry key, which I guess is the hashing of the URI and whether or not we're using some kind of like extension addition to it. Okay. And then if we're doing read only, if the entry doesn't exist and we're doing read only reading and secretly and this network cache pref cache key not found. Okay. If the entry exists and complete only, we're looking for complete files. So if the entry is not ready or revalidating, then we say not found. If we're replacing, if the entry exists and we're not replacing, we want to turn this entry to a memory only. Oh, that's interesting. I didn't know we could convert that. Okay. If truncate is demanded, delete and doom the current entry. If the entry exists and we're replacing it, we're going to doom it. Okay. Ensure that the entry for the particular URL. If the entry doesn't exist, always remove the current force valid timestamp. Okay, we're going to create a new cache entry. No, so we don't include the flags here. So that's it. Like flags were used in a couple places, but hang on. Flags are used there. We don't pass them along here. And we're getting this handle after we create the entry. Which may be the old or the new one. So the flags, open normal is just like ignored. It's just like we don't do anything. Okay. And then storage entry, we come back out. And then we call on cache entry available. Well, we open the entry. Oh, and then we pass the flags to async open on the entry. Okay. Here we go. Flags. We're going to take a lock if we're in the debug log level mode. We'll log some stuff. And if we're debugging, we'll also do some assertions here. And then we will call the callback, which is a callback, which was passed to us. What thread are we on? Oh, so we don't call it, we declare it. Then we call open, passing in one of these. We take a lock, check state under the lock. If bypass and busy. So that's interesting. We take the lock. If the state is writing or the state is revalidating, we return false. Otherwise, we remember the callback. We're going to load we require the lock if loading or loading already loaded, we return false. Not truncating. And then we do this stuff. Loading. And then we invoke the callbacks. Invoke callbacks begin. Invoke first all read write callbacks and all read. Oh, what's RO? Read write, read something. Read only callbacks. Read write and read only. Okay. So we do all read write callbacks. I'm seeing all these locks, and it gives me the sense that there's been a lot of work done here to prevent the kind of races that I think I'm worried about. Yeah, what is this bypass writer lock? I don't like if the entry is being written. Doomed writing, if we're read-onlys and we are revalidating. Stays revalidating, loading, revalidating, cache entry. Callback is not read, write, or read only. Go to another one in line. Callbacks. Okay. So if I make sure that my take hold of the cache entries, and then I want to open them for writing. So NSI cache entry storage, or cache entry storage, yeah. I want to open it to write. Open because we're going to overwrite. We're going to rewrite any existing data when we open it. We're going to truncate it. We're blowing it away. So we will truncate, take hold of the cache entries for both script and styles, and truncate. So open with open truncate. Immediately open a new cache entry. Any existing entries are immediately doomed. This is similar to the recreate method on cache entry storage. We now implement this method and throw. In that case, consumer must use async open with open truncate flag. Oh, this is similar to recreate. Okay. Recreate. If I already have an access to an entry, which I might. I'll probably have like references to these entries. Recreate. Doing this entry and open a new empty entry for write. Consumer has to exchange this entry. The entry this method is called on for the newly created, used on 200 responses for conditional requests. I see. So we will immediately recreate when it's time writing to the cache. When it's time to write to the cache, recreate the entries for script and styles, and hold on to the new references. And then begin streaming I'm just thinking, like, while there's like this little window of time where, like, how do you tell the cache that you're done? Set bypass like to allow waiting listeners to continue even while entry is being written. No, I don't want to do that. If I open streams on them, are they in the process of being open and on? Open blocking input stream to cache data. Use the stream transport service to asynchronously read the stream on a background thread. That's for pulling stuff out. I want to write. If opening output stream to existing cache data, the data will be truncated to the specified offset. Right, starting predicted size. It's a blocking buffered output stream. Non-blocking output stream. So when I call open output stream on this thing, we put ourselves into state ready when we open the output stream. Oh, hang on. If the output stream and we're not doomed, giving phantom output stream. Okay. We'll open output stream internal. What's that? We'll take a lock. We'll put ourselves into cache open close listener, open output stream, prevent opening output stream again. But we'll put ourselves into state ready. The entry is considered ready when the writer opens the output stream. And then we can invoke any readers now. That's crazy because I might not have anything written into it yet. What is that all about? State of the entry. Loading, empty, empty, ready. Transitioning. What? E state, M state, not loaded, loading, empty, writing, ready, and revalidating. Loading or empty. So not loaded will go to loading or empty. Loading will go to empty or ready. Empty will go to writing. When do we go to writing? Because the writes happen first. Oh, I see. The writes will happen first. And then read-onlys. Invoke callback for the writes. Okay. Okay. Claims all metadata are up to date and the entry can now be delivered to other Wayne consumers. We need such methods as metadata must be delivered synchronously. Let's call it the cache health lock. Talking about cache reminded me of something. Do we have something that offers a more fine-grained control of the cache on startup than invalidate caches on restart? What kind of fine-grained control are you talking about? What are you imagining, Danny Colin? Ah, geez. I am realizing now I have not written a single line, and my alarm's about to go off. But this is interesting. I think I've built up some confidence about this process here. Recreate the entries and hold on to the new references. Begin streaming. This puts the entries into writing mode. Take hold, yeah. Stream, parallel stream scripts and styles into the cache. Output streams. If either fail, doom the cache entry. Try again later. I have a script for Firefox on mobile. I need to detect if my autoconfig.js and other files related to bootstrapping it have changed. So this is different from the network cache. This is a different cache. This is restart. Signal the app around and validate caches like the startup cache. I have a script for Firefox on mobile. I need to detect if my autoconfig and other script files related to bootstrapping it have changed. Do you have something that offers more fine-grained control? Not that I'm aware of. Not that I'm aware of, Danny Colin, but that doesn't mean it doesn't exist. The startup cache, for example, ignore disk cache. I think there's like because like in about support, we have this button that's like, about support. It's like clear startup cache. And what that does is clear startup cache button. What do you do? No, it's just calling invalidate caches on restart. Yeah, I don't know. I'm sorry. I wish I knew. If either fail, doom the cache entry. Try again later. Doom the cache entry. Clear the pref value for the hash. Try again later. Once both streams are in, recreate. Write the new hash into prefs. Once both streams are in, set the metadata to include the hash and version numbers. Okay. Right. And then our Moz new tab cached protocol has one job. Get a remote stream from the parent that will either pull from the valid cache entry or will fall back to the built-in one. Which means that we have a bit of separation here. Moz new tab cached protocol handler is the read-only parts here. It just knows how to read from the cache. It does not know how to write to it. It knows how to fall back. The other part is the business around noticing that a new tab loaded and kicking off the deferred task to maybe write the cache out. Write to the cache. An update to the cache. Okay, I can work with that. I gotta go. I'm so sorry that we didn't get... this is just... I'm thinking. I'm doing a lot of thinking here. And you've watched me waffle a little bit, but I feel like I'm getting closer to what I want to do. Thanks. Beep, beep, beep. Yeah, did you hear beep, beep? That's the little space heater. It's very cold in this basement. Thanks again for watching. Or did you hear my alarm? Thanks for watching episode 431 of The Joy of Coding. My name is Mike Conley. That was a lot of fun. I will not see you next week, but maybe I'll see you the week after. Let me know what you thought of this episode. There's a link to rate this episode here at the bottom of the agenda. I'll also drop that in the chat. Link to rate this episode. Beep, beep. And let me know what you thought. I read everything that comes in. It's a great place to ask me questions as well about what's going on. All right, well, have yourselves a great week, everyone. Take care. Bye-bye. Hang on, where is the... Bye-bye.
The joy of coding.
See ya.